Well, can I introduce myself? My name is James McCafferty. I'm the Chief Information Officer here at the Wellcome Sanger Institute. So as well as doing all the kind of standard IT type stuff, I do have certain responsibilities around data, scientific data among other things, and also around informatics. So as you can imagine, I'm very interested in the kind of AI techniques and capabilities that we've heard of today, Francis and Martin. So, as part of this panel discussion, what we're hoping to do is pick up on some of the expertise that we've seen ample evidence of from the different presentations. And I'm hoping, no pressure panel, that we can pull out some learnings, right? So if you're sitting there with problems to do with data or systems, or issues around the people agenda, talent and skills, then now is the time to get them on the table, and we'll have an excellent discussion here. For those online, we do have Slido, and I'm hoping someone's got the brilliant. So we'll pick up on questions at the end. So if we allow ourselves maybe about 25 minutes, we can cover off our conversations and then open up to questions generally. So if that's okay, panel, can I ask you very briefly just to reintroduce yourselves, just to remind people who you are, and say a little bit about your perspective, just generally, on what you've heard here and what it means for your own work. So Maria, do you want to go first?
Yeah, sure. So I'm a professor of natural language processing. My name is Maria Liakata. I work at Queen Mary University of London, and also I'm a Turing AI Fellow. And my work has mainly been around different kinds of natural language technology that feeds into LLMs. And I'm particularly interested in sort of the potential that LLMs have for medical applications in particular, and in long contexts, so looking at sort of diagnostic tasks over time, but also in mental health and understanding the reasons behind model decisions. So yeah, I think this is kind of in a nutshell.
Great, thanks, Maria. Mariana?
I'm Mariana Boroni. I'm a researcher at the Brazilian National Cancer Institute, leading the Bioinformatics and Computational Biology Lab. And my main interest is in omics data, their integration and application on tumor biology, and with a translational focus to identify biomarkers that could help stratify patients and to have a precision medicine.
Great, thank you. Alpan.
Hi, yeah, I'm Alpan Raval. I'm Chief AI Scientist at Wadhwani AI. We are a non-profit based in India, and we do work on AI for social impact across healthcare, agriculture, and primary education. Our charter is really social impact, not so much doing fundamental research. We see research more as a side effect of developing models that affect the communities that we serve. So we have about 30 different projects going on across fields. I gave examples of 2 of them in my talk earlier today. What really worries me as we do some of these projects and as we interact with the people that they impact is the growing data divide, sort of the digital divide, I think it's also called, which is sort of a layer on top of the socioeconomic divides that are coming into society. So it's almost like these data have-me's and have-me-nots. People who know how to interact with data, contribute data, know what's informed consent, know what is privacy, and those who don't. And I'm worried about the consequences of this on, especially as AI models proliferate, synthetic data proliferates, and so on.
Great, thank you, Alpan. Andre?
Yeah, my name is Andre Altmann. I'm an associate professor at UCL in the Hawks Institute, Center of Medical Image Computing. And my research is centered around trying to understand the genetic and molecular basis of brain disorders often. And that's why I'm looking at brain images and also genetics and trying to get health record data and data out of hospitals and trying to understand really what's going on because often we only have very short observations of patients. We don't know their history. We need to guess what their future will be looking like. And it's trying to, well, getting access to representative data and working with it and create models that are actually bias-free and fair to use.
Great, thank you. And Darlington. Hello again.
Yeah, I'm Darlington Akogo, founder CEO of Mino Health AI Labs.
Great, thank you. And thank you, panel, for your time. So, we did share a couple of topics among us ourselves, so hopefully this won't be too much of a surprise. But one of the things that we wanted to focus on initially was about data, and we've talked a lot about it. And I was going to start by exploring the topic, Alpan, if you don't mind, thinking about the kind of learnings that you've had in your projects about how to collect data, especially thinking about AI-ready data. What kind of learnings and advice would you have to people for doing that in a way that supports AI?
That's a hard one. I think the main learning is it's really hard. But I think specifically there's all, I'll give, in the context of the work that we do, there's lots of unanticipated issues in data collection. For example, one of the projects that we work on is estimating infant weight from video, and we had to go out in the field to collect data from rural areas, from remote areas, from people who typically don't interact with smartphones a lot. And we had a basic version of the model set up, and we had a nice prototype with a nice user interface. And we went out in the field, and as a way to motivate people to contribute data, we showed them how it works. We said, well, here's how you use it. You take a video of the baby, and you get the weight. And isn't that really cool? And they were like, it's not a big deal. Obviously, you're taking a video, you can tell the weight. What they found more concerning was, where does that video of my baby go, right? So there's, privacy is certainly a huge concern. It's not just a concern among the more digitally savvy or literate sections of society. It's also a general concern. So I think respecting privacy is very important, and designing your user interfaces that do that, and making sure that your models are not going to consume PII data. I think that's a real challenge. So one of the things we do as an institute is we don't ingest PII data except when it's absolutely unavoidable. There are maybe one or two projects where we do ingest PII data, but we tend to, for most things we do, we tend to remove it at source, so that it doesn't even inadvertently make way into our models. But I think that's very important. And then obviously you want representative data, you want data that reflects the way you're going to use the model, and so on.
Yeah, thank you, Alpan. I think it'd be good to come back to the synthetic data issue in this discussion, but I also wanted to explore, maybe Maria, you're best placed to talk to this one, the kind of challenges and the sorts of techniques that you've adopted in dealing with longitudinal data, the kind of time series data. I saw that quite a lot in your presentation. What kind of learnings have you had on that journey?
So I just wanted to add something on the privacy before we go to the longitudinal. So I very much agree on the issues of privacy. And it's not just the PI data, which is obviously the sort of names, and it's also more subtle. So if, for example, you have particular conditions or particular symptoms, or even when you go to longitudinal data, it's even patterns of behavior can reveal private information. So for example, if we're doing synthetic data generation of someone who's posted on social media, even if you're not looking at what they've posted and sort of paraphrase that, right? So we have a re-identification task to see whether our synthesized data would reveal that person. What is actually challenging is how you sort of preserve the longitudinal aspect, which is kind of this pattern of even just posting at certain times doesn't already reveals something, because you already have a unique sequence there. And so when you move to longitudinal data, it actually, the privacy issue becomes even even more of an issue. But then you do need the longitudinal data if you're going to be, let's say, monitoring someone's health. So for diagnostic purposes, whether this is mental health or sort of, looking at how someone's responding or not responding to cancer treatment, and you have intermediate kind of x-rays or scans and things, you do want to be able to compare with what has been before. But the unique combination of the sequences is, though, an extra signature of that individual. And so I think the combination of longitudinal and privacy preserving is a really tricky one.
And what do you see are the opportunities to provide the safeguards? I think Darlington highlighted that quite clearly about having the safeguards in place for that longitudinal private data. What sort of things?
So I think it's about who has access to this, and if you're then working with models. I think in the sort of the longitudinal data that we feed into models probably it's better if it's synthetic, and so we've removed as much as we can of the not just PI but also other aspects. Because I think one of the issues of the language models is how you control what they give back, right? So it might ingesting these informations and then generating it and for a completely different patient, and then revealing information. So we're looking at the moment on how to kind of mitigate this. But as I said, I think we're looking at it in any case with EHRs, which is some work of a student of mine is doing with NHS England. Okay. But I think yes, the longitudinal aspect still of because it is tricky, and I think that the guardrails there is who has access to this data, and then what actually goes into training models.
Okay, and it's certainly a big challenge. So Darlington, I was really interested in your comments about synthetic data. And you talked about the dangers of synthetic data, but I'd be interested in your learning on when is it right to use synthetic data and when is it not right? Do you have a sense of that you could advise people?
Yeah, I would say if there's a verifier involved, you could use synthetic data. So a good example is this. I think right now for generic use cases, right, the most powerful AI system would be O1 from OpenAI. It was actually trained, most of what makes it powerful is its reasoning capabilities. All of that is based on synthetic data. So the verifier being that if an AI system is generating some math questions and you have some calculator to verify whether the questions and answers actually match and they're correct, then it makes sense to include that synthetic data. There's a data wall, right? Currently we are training AI systems on 15 trillion tokens, right? I've forgotten what the wall is, but I think it's estimated somewhere around 200, maximum 400 trillion tokens. But with synthetic data, there's no limit to how much we can go. So verifiers could be things like calculators. It could be simulators that you have in chemistry and biology. Once you have those things in place, we should definitely leverage more of synthetic data. Yeah.
That's a good answer. Thank you. I was going to move the conversation on a little bit. And
can I say the last thing about the synthetic longitudinal data? So I think one challenge also is at the moment, the longer your sequence, when you're generating synthetic data, the more possibility is that for errors in the generation of the sequence, and that's something that we need to be mindful of and sort of work towards. And so the sequence needs to be both, I guess, consistent with your, I guess, original sequence, but also within itself. So there's various sort of things to try and assess and evaluate there.
Thank you for that. So I was going to move on to talk about multimodal data, and I think pretty much everyone on this panel mentioned it at some point. And maybe this is a question for you, Andre, because in your work in the Hawks Institute, it seems to me as if you're integrating so many different data sources to try and achieve the medical work or robotics work. What kind of learnings would you have for people who are starting to think about other data sets coming from different labs, different places, different data sources? Any key learnings from you?
Yes, so lots, and there's a long learning process. So one thing that initially was always a problem is, if you think of imaging data, every machine is kind of very unique. They're mass-produced on a certain scale, but if the scanner sits in a Universal Hospital London or King's St. Thomas Hospital or something, it's at least a slightly different signature. And the AI system are very sensitive and pick these things up. So you need to train the models in such a way that actually they extract vendor, device agnostic features. So you have to build that in, which is possible, and you can verify it. And there's then the problem that older data, again, looks different than newer data. So we have newer generations of machines. We want to use the old data. And there's a temporal aspect as well. So we need to try to overcome this, again, with modeling aspects. The important thing is being aware that this is a problem. And then testing when it's impacting results, and if it doesn't, and how, and if it biases results. So, so it's a learning process there. So be aware where the data comes from, check for biases. And in the neuroimaging field, we started adopting combat, ironically. And we call it neurocombat. But the field actually has, they started off with the vanilla implementation, but then there's specific things to neurodata that they now implemented and improved on the classic combat. So there's a longitudinal version of it and so on. So there's things to harmonize across data sets now. It's one way to move forward. Yeah.
Okay, that's good advice. I was going to ask Marianne though, because I was very impressed with your work on ovarian cancer, and particularly the single cell work. And single cell, of course, is quite close to our work here at the Sanger, right? But it seems to me that almost on a regular basis there are new instruments, new insights. Again, how do you and your work go about bringing those data sets together?
Yeah, sure. Going back to this multi-omic problem, when we are integrating different omics, I think we have this problem of having a great data set because right now there are only few cohorts available where they have profiled different omics of the same patients, and sometimes they are not accessible to everybody, so it's something very limited. And when you are integrating data from different places where they have profiled different omics, then you have this missing data problem, which is also very difficult to deal with. And also, when you are scaling to technologies such as single cell data or even spatial transcriptomics data, then the number of features scale up a lot, and then you need more powerful computers, and this again hits another problem, which is access to this kind of instruments. So working with this kind of data in low resources countries, it's very challenging, and I think we are very creative in a sense that we are trying to analyze this data and come up with new solutions in terms of reducing features to be more like to reduce the cost of like the computational power and so on. I think that's it.
So, well, thank you for that. Can we just touch back on security and privacy? We did talk a little bit about it earlier. And one of the things that Tim Howard in his presentation yesterday struck me was this idea that AI models can embody the data that they were built with, and there's issues of security and privacy around even publishing models. And I wanted to get a sense from the entire panel as to the extent to which that's an issue, and how can we manage around that. And maybe Maria, you'd like to touch on that first.
Yes. So I think, one solution is to try and, as we've said, sort of train on synthetic data when it comes to really sensitive, records and so on. And I think, though, that making the weights of models available, so in kind of open source models, is important. And so there is obviously this juxtaposition between the possibility of, if you sort of try and if you have an open source model, is it sort of more open to attacks? I think that in the end, I guess if you really have issue with sensitivity, well, we need to have a lot of evaluation for this. It's a big open question, right? How do we properly evaluate for these models? How do we, properly check for privacy leaks, and then put in the mitigation strategies? But I wouldn't not share open source models for that reason. But yes, if it was strictly proprietary data that we couldn't be sure that it wouldn't be accessible from attacks to the model, then I guess I wouldn't share models trained on those particular data.
And Darlington, I'd be interested in your perspective on that. So it seems to me as if Moremi is dealing with quite a lot of patient data being trained. How to protect that if a model does come under attack or investigation?
Yeah, there's a number of things you could do. I think we've highlighted them. So yes, essentially, okay, so I do have a question. I was trying to not bring it up, but if, for example, for medical use cases, yes, I can see that being a problem. You gave a use case for social media, right? Where due to the style of post, you could potentially identify who it is, even if you remove the PIIs. But in that use case, the challenge I have with that use case is that social media is actually public data, right? Anyone could go on your Twitter page, unless your account is private, which if it were private, probably whatever crawler is being used or whatever scraper is being used wouldn't get access to it, right? But if it's public, anyone could go on your Twitter and see your tweets either way. For medical, yes, but the most important thing for us is to remove that PIIs, right? So even if, let's say, someone were to somehow get access to the data, they could see, okay, there's a patient that has breast cancer and they are on these medications, but they don't know the name of the patient. But PII is not just names, right? So if you don't know someone's name, but you know someone's date of birth, you know their gender, and you know what city they are in, you could always, just align that with any publicly available data, and then you probably know who it is. But so PII includes those two as well. And the balance between that is always tricky, right? So if you are overly protective, you end up not doing anything with AI systems. You don't even give them any data because you're too worried. But if you're also too much swung on the other side of the pendulum, then what happens is that you jeopardize people's privacy. So we always try to strike that balance. But some of the safety guardrails is actually making the AI system pretend to not be capable of things that it's actually capable of. I'll give one good use case. So we found out that our AI system can actually generate upon command highly toxic compounds targeting specific things. Mm-hmm. If we told it that generate some sort of compound that targets the nerves, and you describe it, it's able to generate it. If you want it with higher toxicity, low toxicity, it's able to do that. Clearly, we don't want the general public to have access to that. So, as part of the safety guardrails, if you ask it those questions, it will tell you, I cannot do it, which is not true. It can do it. So, there are a number of those use cases that we've identified that it could do, and we just tell it to refuse to do it. But yeah, the question I passed on to you,
I like that example though, Darlington, and it just shows the power of the technology, and it has to be used appropriately. And for personal identification, I don't know how true this is, but I remember being told that just 6 simple, non-personal questions will identify pretty much anyone in the UK. It doesn't take that much to do it. Can I ask the rest of the panel any other kind of views on this idea of the model sort of embodying the reality that was used to create it, and how we protect that? Any other views?
I mean, in medical imaging, we have the same issue. And so there was a paper, I think, that linked brain MRIs, which contain part of your skull, to actual images of people. So that's, of course, concerning. In the end, it wasn't that great a use case, because it was a limited set of which pictures the system could pick on, so 1 out of 20 or so. But still, as a consequence now, for many stuff, when we share data, it's actually problematic. We cannot just share the clean MRI data. We actually need to deface it. So we essentially delete part of this, which again might change how the data looks or is being interpreted, because it's not something that would be used by the clinician, like a defaced image. They wouldn't put that into any system. So then an alternative is to create generatively create a standard face on top of it. Again, it changes kind of the data we're working with, but this is something we need to think of in terms of identifying and de-identifying data, so it makes things a bit more complicated. But it's one funny case.
Okay, if there's no other views on that, I was going to move on, and this is more about the kind of people side, particularly thinking about the fact that so much of our work is an intersection of different domains, between biology and the plethora of domains in there, and computer science and data management and data engineering, those kind of things. And I'm conscious there'll be a lot of people here either recruiting or trying to develop people in their teams with those kind of skills. And again, I'd like to ask everyone on the panel their learnings and their suggestions for how to attract the right talent, how to develop those kind of skills, and also a little bit of how to deal with the intersections. I always say, is it easier for a biologist to learn about AI, or does it go the other way? So just a bit of insight onto that would be helpful. And I don't think Alpan has spoken for a while, so do you want to go first on that one?
I think that's an interesting question. What skills do you look for, and what skills do you develop? I think it's certainly easier for people from more quantitative areas to pick up domain-specific knowledge. For example, if they're working in biology, I know it's probably easier for this may be a controversial statement, but easier for people from a quantitative field like computer science or physics or math to pick up biology than the other way around. But I don't think you can replace domain knowledge. So there has to be a willingness and an interest in the domain. I don't think you can just be an AI expert and sort of generally work on problems unless you want to do fundamental research in AI.
Yeah.
But you have to understand the domain. And one of the problems that I've seen over the years is with the advent of deep learning, there are a lot of young people just throw a neural network at a problem without thinking about it, right? I don't know if it's a problem in the UK, but certainly we see this in India. You give them a linear regression problem and they throw a neural network at it. And so this is a danger, and I don't think they understand. They don't try to model. They don't try to understand the data, understand what are the inputs, what are the outputs, what features might be useful, what features are probably not useful. So everything we learned in the old days when we were doing feature engineering, I think is still important, just in order to understand the problem. And I think that goes a long way. So I think some of these skills, data skills, curiosity about data, willingness to understand the domain, in addition to the computer science skills. But I don't think it's optional. I mean, I think you really need these other skills.
Okay. Thank you, Alpan. Marianne, do you have a view? I'm conscious people talk about T-shaped skills and V-shaped skills and things like that. So for your research group, I guess that must be something in the front of your mind.
Yeah, for us, mainly most of my students, they are transiting from biology to the computational field, so it's the opposite, the majority here. And I agree with you, for us it's more challenging because, for them to learn all those computational stuff takes a while. But I agree with you that this is a very collaborative environment field, and there is no way of you avoiding this intersection between experts in biology and experts in machine learning and data science. And regarding your question about attracting those people, AI per se, it's a word that make them very curious about. So to attract people to this area, I think it's super easy. The problem is to keep them in this area, especially in academia, because at least in Brazil, and I think I can talk regarding South America, the salaries in academia are not competitive regarding salaries in industry, right? And the way I see we filling this gap with header increasing salaries, then sometimes this is not possible, but I would rather invest in training, so then we can spread and enhance the capacity in those locales.
And it takes a kind of individual attitude to want to pursue a career in research as opposed to moving into the finance sector, which is where a lot of people go.
Exactly.
Maria, do you have a perspective on it? Because I'm conscious you had quite a lot of collaborators listed in your work.
Yes, so I'm quite used to now working across disciplines, and I think there's great value in having multidisciplinary teams, and also both in terms of the experts involved, but also having students with different perspectives, coming from different backgrounds. Because obviously, as everyone said before, we see the people who have a numerical background, whether this is in maths or computer science, are going to pick up the computational algorithms more quickly. But I think the perspective on the problems is really important, and sort of intelligence does not just manifest in sort of being able to write algorithms and understand algorithms. And there's some really bright people I've worked with who do not have a computational background, but are very good at thinking about the problems. And so I think you need people with kind of both the sort of understanding of the problems and being very good at sort of the problem solving. And I think that's where real success comes, at sort of bringing these two together. I mean, you have individuals who have both, right? And that's quite rare and amazing when you find them. But I think for teams, you do want to have multiple perspectives, and you just don't want people who treat the different problems as all being the same. Yes, there is an element of there being pattern recognition everywhere, but it's sort of understanding the data and the domain problem is really key.
Yeah, absolutely, I would agree with that. And I was going to ask Andrea kind of follow-up related to the skills side of things, because it seems to me more than anyone on the panel, Andrea, you're having to deal with so many different moving parts around the different skills, the capabilities that you're looking for, the deliveries and the like. It must be very hard to bring people on in that space where you're dealing with so many different modalities, plus the robotics, plus the people side, plus the medical and clinical side. So how in your experience, what's the best way to bring people on in that kind of environment?
Curiosity.
Good one.
I mean, it's different people. So we have some people who are more on the engineering side, and then people who are interested in interacting with clinicians. So in the center, usually we have clinical, also in the institute now, clinical co-leads to bring that expertise and to make themselves readily available, because it is exactly that domain knowledge that makes or breaks something that is useful. Because we often see, and that's especially in the Alzheimer's field, the data is available, and then research groups go there and say, oh, I'm taking brain scans and I'm making a classifier for Alzheimer's against controls. But nobody in the clinic needs that. And that's paper coming out, is this performance, but this is, it's a toy problem. And, you have to cross-talk permanently, and people are interested in trying to solve something like this in order to make something that's actually relevant. And you don't waste anybody's time and compute resources, and try to engage with people, with stakeholders very early to see what is actually the problem they want to have solved. So then it turns out like it's not Alzheimer's or not, it's like, oh, somebody has a memory problem, will they develop Alzheimer's, yes or no? That's really the clinical challenge there. And you need people who are curious, and some people, that's why we're also cohabitating with the AI Institute, for instance. So these are people who are doing mainly foundational AI work, and they just do a lot of formulas and develop new stuff. And then in the end we see, oh yeah, that could be useful to us, and then we try to mix and mingle. So it's having different people, and interdisciplinary team means you have different people with different skill sets bringing together and trying to be willing to engage with each other and try to translate between each other's language as well.
What comes down to people. And Darlington, I was going to ask you your perspective on it, not just from the point of view of developing skills, but I think you particularly mentioned the complementarity across different disciplines. How do you manage that? What kind of advice would you give to people?
My fellow panelists give very brilliant answers. I don't know if there's any more I could add to it. No, I would say, so on one hand, sometimes it's just best to put people of different backgrounds in the same space and just let them have like very, very long conversations. Yeah. I've seen that to be very useful. I mean, you could have like some specific topics that you want them to discuss and come to some conclusion on, but if you just let them have like those long conversations, so many things develop out of that. But for skill sets, what I've realized is this. So this is what we do. So first thing first is set highly ambitious goals, because it tends to attract like super, super smart young people. And then the next step is that we don't look for people who have, like, especially on the computational side, we don't look for people who already have the skill set of LLMs and foundation models. We're just looking for super smart young people. From my experience, we've been able to train people in a period of like less than a month, especially if they already have some computational skills. So if they already know computer programming or they've already done some machine learning, they can go from that to knowing how to train foundation models in like a month. And I am of the belief that people who actually come from biology will find it easier to learn AI. Because to be honest, like, the AI stuff's not rocket science, not really that complicated.
Don't tell everyone,
Like the transformer is a very simple architecture. So it's easier for them to move on that end than the other way. That's from my experience what I've seen. So if you have smart people and you give them a really tough problem, they'll go figure it out. Like, they might overestimate, which is what happened. We thought we could get it done in a couple of, like 3 months, it ended up being 2 years. That will happen, but they would eventually figure it out. So, and I think a bunch of labs are also doing the same thing. So Open AI, Anthropic, they have this fellowship program where they are looking for people who have background in like biology, physics, math, and then you take a couple of months to transition into AI. And those people are some of the smartest people you meet, because they are not just coming with an understanding of neural networks. They're coming with ideas that have not really been exploited yet within neural networks. So yeah, I see that actually works much more. But have this multi-disciplinary team and just let them hang out. We have like games where, like right now we are super obsessed with our 4Connect. So play 4Connect and just hang out, have conversations, and so many interesting things come out of that.
Good advice, thank you. And thank you to all the panel. I think we do have time for one or two questions, either in the room or on Slido. And again, I would stress, we've got a lot of expertise and experience on this panel, so do make good use of it.
So we have multiple questions online, but if it's okay, I'll start with my own question. There is huge diversity, like James said, from biology to physics to computer science, but also you guys are representing 4 regions in the world, and industry, charity, as well as academia. I would like to hear what would be the golden data infrastructure you would like to see across your regions, where you could safely share data, have privacy, have the ethics taken care of, and do this amazing research that you all want to do. What does that look like? And with all the regulations and the bureaucracy we have, how do we get there?
Okay, so Priyanka never asks an easy question, right? Okay, so that's a toughie. In an ideal world, what kind of infrastructure, platforms and setup would you like? So who wants to pick up that one?
I can start.
Oh, is that because you've got it already, Maria?
Because I've been thinking about it, yes, because data is such a plague for us, right? You don't want, you have always the issue of having getting access to the data, and sort of different researchers. If some researcher changes in your team, can they still access your data? What happens after the project is over? There's so many issues around sort of data preservation, data access. And I think that it's not something that individual research groups can do or should be doing. So there should be more sort of centralized places that sort of curate the data, look after the data, and perhaps these could be made accessible through safe data environments, so SDs, which have already started being set up. Now, having worked previously with data safe haven environments, they can be quite quite hellish to work with, really. Especially, we tried to set up a shared task in a data safe haven environment. In the end, it didn't work because we couldn't be updating the needs for the models quickly enough for that to happen. So we need to sort of make these environments flexible so that actually people can develop their code and solutions at sort of a realistic time, and because obviously when we're developing our models, we don't necessarily know everything we will need from the start. So allow this kind of iteration between sort of access to data, model development in a way that's sort of safe for the data, but also flexible for the researchers. And I think that should be, projects, individual researchers and projects shouldn't be struggling every time to get data access and in sort of data, different kinds of versions of the data and so on. So I think that's my view, and that's also how you could protect data as well. So that you don't in the end, if you were, for example, to have benchmarks being set up that evaluate some of these models, they wouldn't get ingested in the new iterations and the new versions of the models. So if they were sort of in a sort of secure kind of environment where you're posting the model, but in making sure that it's not sort of leaking data back. So I think that would be my kind of ideal. Yeah.
No small ask. Any other views from the panel? What would you like in an ideal world?
So I don't have sort of a holistic answer to this question. I've never thought about this. But I think in an ideal world, I'd want the data annotation problem to be solved. in a way that's not exploitative but still human. I don't think synthetic data is the answer. In fact, there's been recent work in the context of LLMs that shows that when you go through the synthetic data cycle, LLMs generating data and other LLMs trained on the data that's generated, you get model collapse eventually. And I'm worried, in the biological context, we already have all these structures generated by AlphaFold out there. There's going to be more synthetic data out there, and without watermarking, without ways to identify or distinguish between synthetic and non-synthetic data, it's going to be very hard to train models, and you will need human-generated. You will need human annotations. Currently, large-scale human annotations are done in an exploitative manner. So I don't know how to solve that problem, but I think that problem needs to be solved.
And it's certainly a problem. Maria and I were talking a little bit about this, with more and more AI-generated information pouring onto the web, pouring onto social media. It's almost as if now is the last opportunity to fill your boots with real human-generated information, right? Because from now on, there won't be so much of it, relatively speaking. Any other views? Any other items for an ideal world? Okay, well, do we have other questions?
Yeah, we have lots of questions on that. So Adam is asking, delivering ML projects requires diverse expertise. In your experience, which skill sets are undervalued or under-recruited when building ML teams?
Undervalued and under-recruited. Okay, that's an interesting question. Any takers on that? Thinking, I guess, in the round about building up a capability, what are the undervalued skill sets? So I think Darlington highlighted this idea of people working together, and I think Andre was talking about a kind of problem-solving approach. Any other sort of undervalued skills?
The willingness to do the dirty work, to data clean. I mean, everybody usually, especially in university, comes in and wants to train their neural network, for better or worse, and they're not willing to prepare the data. So that's definitely, if you want a good model, and you said it, you need good data. So the willingness to dive in, engage with it, and see, and try to understand first, what is good, what is bad, what's causing problems. I think that mindset is undervalued at the moment. So it's not, and that's not a pure math skill. That's really just down to, getting your hands dirty.
I think also research engineers. So these are not just software engineers, but they're people who can understand the problem. So it's usually people who have PhDs who've worked in research, but are also very good developers. So I think that's quite a rare skill set, and sort of they can pick up prototypes and sort of create things that actually you can use with real users, and I think that's something that research teams are lacking at the moment, because it's sort of the making the transition between having a paper and some code to actually making some impact.
Yeah, that's a good point. Now, do we have time for one more question?
Yeah. I'll ask the most voted one. So when benchmarking models, how can one reconcile transparency of that research while avoiding incorporation of the benchmark into the next model's training?
Okay. Well, benchmarking is fraught with problems, we know that. Maria, I'm looking at you already.
Yeah, so I kind of hinted at this, that I believe that we need to protect the benchmarks, and so a way of doing this is some kind of secure environment, I think, where essentially the model has to be evaluated there, and sort of it's not widely shared. Now, the exact details of that implementation we're still trying to work out, but I think that's kind of the model that I would think would work. And again, I don't think this should be individual research groups, but I think that's something that a more central organization should be essentially. I don't know whether this is going to be something like the AI Safety Institute or the Turing or who, but I think in the end, sort of evaluation that is being developed by individual groups should be coming together, and sort of models sort of passing through maybe some kind of certification in sort of this kind of more central body.
Great. Well, shall we wrap it up there? I'm just kind of conscious of the time. Thanks very much, everyone in the room, and also on Slido as well, some great questions. But special thanks to our panellists for bringing a bit of humour, a bit of expertise and a bit of insight into these tough issues. So special thanks to Darlington, Alpan, Maria, Andre. Special thanks to Mariana, who has now done 2 of these. So thank you for that. And let's give them a big round of applause. Thank you very much. Thank you, panel. Now, I think we stay with me, do we? Yeah. I have the honour of giving some closing remarks. We are overrunning a little bit, so I've decided not to give you the 1-hour speech you'll be glad to hear. And it's normal at the close of an event for someone just to give a little bit of personal reflections on the event. So I will do that, but I also wanted to just give you a little bit of an insight into the work that we're doing at the Sangers. So for those of you who aren't familiar with the Sanger Institute, our origins come from the Human Genome Project, which goes back 20, 30 years. And we contributed massively to that. I think about a quarter of the entire initial human genome came out of our labs. And since then, we've been picking up on all manner of genomics-related research. So we're now quite a sizable institute. We have about 1,300 staff, and about half of those are research scientists. We pride ourselves on science at scale, and that basically translates into generating massive amounts of data. So as the CIO, I get to see the sharp end of that. We've got about 90 petabytes of the stuff. And that's by no means the full story. We pass a lot of data into EBI, who provide that publishing capability, and they have about 4 times as much data. So yeah, we're very much about open science, sharing that data. And it did occur to me, just listening to some of the presentations, it's largely a huge resource for the kind of projects that we've seen in this room. And I know that both John and Priyanka will be very open to discussions around collaboration as we go forward with it. The main use cases for AI and ML that we're seeing in our work, at least, there's quite a chunk around modelling cellular mechanisms. There's a lot of work that we're doing in histology, image analysis, spatial type techniques. We do quite a bit of mutation prediction centred around genomics, and it was great to see a few of the poster papers just yesterday covering that kind of thing. But we also use AI in other kind of scientific related ways. So one of the new ones that's quite exciting is around gene editing. In fact, just to give you an insight into the growing confidence in the genomics community, we often now don't refer to gene editing, we talk about gene writing, right? And if you get the subtleties in that, it gives you an indication on the perspective. We've been working on generative models, particularly to feed into synthetic biology, which is a big thing for the future, and also de novo sequencing. So one of our programs is the Tree of Life program, and it aims to sequence the entire genomes for all species in the UK, so that's over 70,000 different species. And that's de novo sequencing, and if you think that it took, 10 years, more than 10 years to come up with the first human reference genome, the Tree of Life program are churning them out on a weekly basis. It's a massive endeavour. So I wanted to give you a sense of the kind of AI aspects of what we're doing, so automating those kind of processes as well as doing the science. So as regards general reflections on this event, I don't know about anyone else, I have had a fantastic time, I really have. Just listening to the presentations, I've been so impressed with the kind of practical nature of what we've been talking about here, the workshops that we've had, the hackathons, the tutorials, as we all get up to speed in some of these new technologies. And I think that's really important to have that for what is a very exciting and emerging field. And I wanted to just highlight a few things. One of them is, and we kind of touched on this in the panel, a lot of what we do is about getting the right outcomes. I know the tech is great, you know, the data is wonderful if you work through it, although I take Alpan's point about the curation piece. But all of that together is just for one thing, and that's the outcomes. And we are in a privileged position when you think on it, and I think Darlington touched on this. We're in a privileged position for right here, right now, the tools that are emerging, the technology, the data, to make that work for society. And it's as much as possible a global aspect to this. I think COVID certainly made that very clear to all of us, that we do not live on an island. Allied to that, we often hear talk about the digital transformation of science, because so much of new instrumentation, new techniques, new approaches, across all aspects of human endeavour, it's digital, it's data, it's forever growing. Well, the same applies to science, and we'll see more and more techniques like AI and automation play through into science, so that it doesn't just make science better, faster, cheaper. It will change the way that we do science. And I think we've seen, as we've talked about, the foundational models and the like, that the changing way that we do science will make, well, we call it dry lab, you know, working in informatics, much more important than it has been previously, where we'll see scientists, first of all, going to foundation models to evaluate potential hypotheses, try out the scientific questions. So that will, again, change the nature of what we do. And I think we saw here over the past few days quite a clear indication of that. I wanted to touch on the nature of collaboration. Science is a team sport, and certainly AI in science has got to be a team sport. I reflect back, so this shows my own, I did a PhD in computer vision, and that at the time it centred around competition. So the ImageNet competition, and more recently the CASP competition, where different teams were working on different AI approaches to solve problems. Yeah, I get that, and that's fine. But generally it's about the community, and the community will move forward or not. And it's been so lovely to see so many researchers and so much insight coming from right across the planet for all of this. It's been so wonderful. But again, I wanted to stress that. I also wanted to stress that it's not without its challenges. I think we've talked about explainability and trustworthiness. We've talked about hallucination and the like. I would also add into the mix scalability, right? And this idea of being able to develop new techniques that are sustainable, that don't burn up the entire planet's energy resources. And that's a challenge not just for this community, but for AI generally. And I think we, as a bioscience community, can be working with AI researchers to help them take on some of these challenges. A good example of that, thinking again about foundation models, is this idea of pre-trained models. We need to be doing more of that, but also making sure that the models that we use are effectively interoperable. And I was talking to Matthew earlier about some of this. So there's some good work happening in that space, that you can almost have a kind of pick and mix approach on foundational models when trying to model biological artifacts. And the ethics side of things, and I don't mean ethics in a kind of soft, fuzzy way, but it's down to aspects of governance for what we use these models for and what we train them for. So, for example, in the Sanger, we've just recently adopted a policy about increasing the diversity of our research data and our research generally. Those of you who are familiar with genetics, there's been a massive, just generally a continued focus on people of European origin. But when you think on it, that's tiny compared to the genomic variation across the planet. So we've got the message, and I think it applies very much here about making sure that we do avoid bias, and we do work with diverse data sets. The last point I wanted to make was some of us went out to dinner last night. We had a fantastic time. I don't know what it was like on some of the other tables, but we were talking about what is science going to look like 30 years from now. No small challenge, no small challenge. We had some great ideas on our table. The best one, where's Marianne? The best one was, we'll all end up with little devices that fit in our ear, right? And if someone's talking to you maybe in a language you don't understand, like Portuguese, there's the translation. And then how does that fit with augmented intelligence, where you're going to start end up with chips inside your head and stuff like this? So that may all sound a bit futuristic, but when you think 30 years from now, and again we saw it in some of the presentations, the idea that AI models can start to form hypotheses and start to perform their own investigations in the world, and I think Darlington brought this out really well, it accelerates the science hugely. And one of the techniques that we are looking to do further work on is this idea of lab in the loop, where the AI model can effectively request experiments to be carried out that feeds data into the AI model. So the AI model is on a journey of discovery. Although I do like Darlington's idea that we'll end up with about 10,000 scientists in the Sanger. I look forward to that one. Okay, so it remains for me to thank everyone for attending this event. Not just the conference, but the workshops, the tutorials, and the posters and the hackathon. I think it's been a fantastic event, so thank you very much for that. These things do not happen by accident, so special thanks to John and Priyanka and all the team who have pulled this together. Special thanks to our speakers as well. The presentations have been truly fantastic, and I personally have learned a lot from them. Looking to the future, building on the success of this event, I'll be very keen that we keep this going. So please do keep in touch with Priyanka and John. As I said, there's lots of opportunities for collaborating in this space, particularly for institutes like the Sanger that are data rich. So please do keep in touch, and we'll keep in touch with you as regards future events as we take this forward. So what I would suggest is that we give a round of applause to our speakers and to our organisers. Well done.